Hello, welcome back to my channel. Today we are going to solve number 234 of Leetcode. Problem statement is palindrome linked list. It says, given a single linked list which only has a next pointer to its next node, determine if it's a palindrome or not. For that, question arises: what is palindrome? Palindrome, um, a palindrome string can be defined as like when you switch it into the half, uh, and the reverse of the half is equal to the first half. Let me explain you visually. Let's say I'm talking about a number 1 2 3 4 4 3 2 1. So they are palindrome. How can I say that? Because last character is the first character is equal to last character, second character is equal to second last character. Similarly, all those conditions. Uh, for English word, I think there is a word radar. It's also palindrome. Why? Because first is equal to last, second is equal to second last, and if you don't have like if this is an odd length variable, so you can ignore this one. So this is equal to itself. So I can redefine the definition of palindrome as if it's a odd length string, then you only need to check uh, till the first half and last half, leave the middle part, don't check about it. If it's even, you can get a full half of the like full first half and full second half. Now what, coming back to our example, let's say example is 1 2 3 and 3 2 1. This is palindrome. It's an even thing, and side by side we will check for odd as well. It says 1 2 1. This is an odd string. Let's only talk about the odd. Even as a string, I'm not talking in the terms of linked list right now, just to make sure what is palindrome. So over here, if I want to check whether this string is palindrome or not, what can I do? I should be finding out the middle element. So the length is 1 2 3 4 5 6. So these are the indices. I'm starting my indices from 1. So if I say 6 by 2, the size divided by 2 becomes 3. So this becomes my first half, and this becomes my last half or a second half. Now what should I check? I should check in such manner uh, whether I can reverse the second half or I can reverse first half. So let's reverse first half. So if I reverse the first half, it becomes 3 2 1. Now is this value equals to second half of our original string? Yes. 3 is equal to 3, 2 is equal to 2, 1 is equal to 1. In the case of odd, it's 1 2 3. The size is 3 divided by 2 becomes 1. So I have to take first half from here and second half one length here. I can ignore this one, so this has to be ignored. Okay. Now if I reverse string from the first half, it becomes 1 again. So is the resultant from here is it equal to second half? Yes, it's equal, then it's a palindrome. So that's how the intuitive way of thinking about given string, uh, it's the intuitive way how we can think about whether the given string is a palindrome or not. Now things become trickier when it comes to linked list. Linked list is not a single string, so you cannot access it using the indices. It's like we are nodes, and first node has value, second node has next character. So here would be the next characters. So let's say the value is 1, 2, and 1. And this last next points to null. Uh, this is null. So now, uh, firstly, what we can do is we will try to check what's the length of this linked list. If the length is 3, or in the uh, generalized term, if the length is odd, then I should get a first half by dividing this size by 2. So let me just divide my size by 2. So this becomes my first half. That's I'm sure about. Even if it's odd or even. So since the size is 3 by 2, it becomes 1. So I'm sure that this is my first half. There is no doubt about it. Doubt is only there for the second half. If size is odd, then I have to ignore this element. In that case, my second half, where does my second half start at? So my second half would start at first half plus 1. That means whatever the value first half has, plus 1, it becomes from here. So from here till the end, this is my second half. In case of even, I'm very much sure that after the first half, I have my second half. But in the case of odd, you have to ignore this element. Okay. Now let's move to question statement again. They are asking a follow-up question as well. Can you do it in O(n) time and O(n) space? So before jumping to that advanced level, let's talk about the normal level, how we can do it. So in the normal level, uh, now we have knowledge about checking our first and second half. So this becomes my second half in the odd case. What I will do is I will reverse my linked list, uh, that the element residing in the first half. I will reverse the element whatever the element resides in first half. For reversing the linked list, easiest approach is using a stack. So using a stack, what you can do is you start pointing at head and go up until your stack size becomes um, first half size, and first half size is equals to size divided by 2, right? So stack would contain ptr first. In case of this, it would contain 1. Let's assume if there is one more element, 3. Okay, and there is one more element up here as well, so it becomes 3. I want to make sure we fall into the palindrome category. So here size becomes 5, first half becomes 2. So I am sure that my first half boundary lies till this area. So this is my first half and this is my second half. Now coming back to the stack thing. Firstly, my pointer would come to the head of the linked list, which is 3. So in the stack, I would put up 3. Then I can put up 1, and then I have stop, because the number of the stack size should be no more than first half size. So first half size in this case is 2. Okay. Now what can I do next is I will make my pointer to point at my second half list. So basically there should be a pointer which would be pointing at my second half. So it points at 1. So what can I do from here is, uh, in a very basic intuitive naive approach, you would have ideally made converted this stack into linked list again. So you can make a new linked list. Let's say ptr2 now points at, keep popping up stack element, it will become 1. Then you pop again the second element, it becomes 3. Then stack becomes null, and from there you can compare your first half and your second half. But we can directly do this as well. So instead of making a second linked list, keep popping your stack elements until the stack becomes empty. So keep popping it. So if I pop this out, this one goes down from the linked list, and I always have the pop element access from stack. So my current pop element would be 1. We don't care about where does it point to. I'm just concerned about the value. So you just have to see whether my pop dot value is equal to ptr dot value. If they are equal, I am fine. If they are not equal, I have to exit and return false. But if they are equal, I'm fine. I can continue. So in the continuation process, I should make my PTR move to the next pointer. So PTR should be moving to next pointer. In this case, PTR should be equals to PTR dot next. Visually, PTR should move here. Getting the point. So this is the way we can use it. This way can be used to solve this purpose, and I have tested it. It worked fine. So, but there is a follow-up question in our lead code. They are asking, can you do it in on time? So our complexity is on, but there is a doubt in the case of o1 size. O1 means constant space, but over here our space varies as n varies, because space in our terminology can be, if we're talking in the terms of big O n, it becomes n itself, because n by 2 is closely related to n. So my maximum value of the stack size would be n by 2. Yes, am I correct? So in that way, our space complexity of this approach is O of n. So what else there can be? Another way Another way would be to use advanced way of recursion. Um, so let me close this stack approach. Now in that case, I'm sure that in on time I can move my PTR against start of second linked list pointer. So this would be my head of second linked list. That way we are done. Okay. Moving to the next part. Without using space, we can use recursion. Yep, somebody can say using recursion we internally use stack, but the interviewer can say like recursion, in the recursion process you can assume that there are no stacks, the things are there in memory cache or something like that. You can put up any argument, you don't have to argue with the interviewer, you can just follow whether I can use recursion or not. And you have to ask this question, because this way the interviewer will get uh, like good knowledge and good impression about you, whether you have good knowledge about the complexity of details of solution questions or not. So do ask the interviewer whether can I use recursion or not. So if they say yes, you can move ahead and you can proceed with your second approach, which should be like this. So in the recursion manner, there should be a function. We can call it recursive function. Okay, just in the visual approach, just to visualize. So in that case, we would be passing out head pointer. Okay, and what else I have to pass? There has to be a termination base termination condition. The return type of this function would be boolean. Okay. Now the base condition for it to be the size of first half. So first half size should be my number of comparisons. So I can put on like comparison left, and to stop this base condition, I will see whether my comparison left is 0. In that case, return true. Else you have to proceed. You can use recursion, and over here instead of head, place head dot next, and comparison left. Don't decrement using a postfix operation, because in that way you will use the value first and then decrement it. So better increment the value first up here using minus minus and use, and it will return you some kind of a status. Okay. You can check whether the status is false or not. If status is false, you don't have to do any more operation, right? Now if the status is not false, um, you have to check. So there has to be a function check which checks for the conditions. And what condition has to be checked? Whether my first half, so in that case in the recursion manner, right, to the recursion stack, 3 will be passed first and number of comparison would be 2 in the first base call. Now the recursion happens in the place, and when we say head dot next, we say 1 internally, and we are decrementing our comparison loop as well, so it becomes 1. Now for next thing, because my recursion comes here and comparison becomes 0, since it becomes 0, it returns true to its last function. So this one gets out of the stack, and this has a status as true. Now they have to check. What they have to check? Whether this pointer is equal to the second list pointer. If they are equals, you can proceed. If they are not, you have to break your loop. You can simply return false, right? So that's the way. Again, uh, in this case, it would return true because 1 is equal to 1. The values are same. So what we have to do is, we don't have to make any effort to bring back our head to here, because recursion automatically does that. In this case, if recursion stack gets deleted from here, it will automatically point to 3, which is this value. But we have to manually move our pointer of second half to the next location. So in that case, our function check should do some kind of operation to move our second list pointer to its next value. So if I have moved my pointer to my next value, pointer stays here, and in this case, the value becomes first half value is 3. Is it equal to the current pointer location? Yes. If everything goes fine, it should return true. Otherwise, there has to be break somewhere that returns false. So let's see how we can write this code. Actually, I have already written the code. I am going to show you a quick walkthrough. They just had given this function boolean is palindrome list node head. From here, I am trying to find out what's the size of this linked list. So I'm initially making the size to 0 and checking whether till my pointer is not null. I will keep on moving my pointer to the last, which will bring me the size of my current linked list. If size is 0, there is nothing to check and I can safely return true. But if there are some values, we have to check. Even we can check for size less than equals to 1, that would also do. But it's okay. Now moving to the things, my first half is equal to size by 2, that's for sure we know, but there has to be some condition for second half. So for that, firstly I have made second half equals to size by 2, and I'm only touching my second half value if it's odd length list node. In that case, second half becomes plus plus. It becomes incremented by 1. Now there is a counter which moves. The logic of this code block is to move my second list pointer. So if you see, I have declared a global second list head pointer. It will move till uh, uh, the exact location of second half. And how does it do so? I'm checking my counter starting from the start, because second list over here points to head. So I can move this condition down here. They make sense together. Now second list is incremented to its next value, and counter is incremented, and we are checking whether we reach second half head or not. When we reached, we are done, and the second list uh, is set wisely. Now there is a recursive function, but before we go down there, let's talk about our approach one solution also. If we don't use this function, we can do it like this. We can make the pointer to head again. There has to be a one pointer, making a count to 0 again. And in this case, I'm doing my operation till the operation count is not equal to first half size count. There is a stack of type list node. I'm keep pushing the elements in the stack, and I'm keep moving my pointer forward to the next location. Now in the next code block, what I had done previously was I popped the element from stack, and I checked whether my popped value is equal to second list value or not. If they are not, I can straightly return false. But if they are equal, I have to move my second list pointer to the next one. But the Leetcode asks to solve it in open space, and therefore we have used a recursive function. It is a is pal helper. It contains the first argument as list node and second argument as an integer which states the comparison left. So from here it's more readable, comparison left or not. So over here, if comparison left is 0, it means with the help of recursion and internal stack, we have moved to the last of the first point. The first head has moved till its end, and we can't check it from there. So we are just returning to, and after that there is a status check, because each time this will the due to this first list dot next and comparison minus minus, there has to be a condition where comparison will be equal to 0. So for the first time it would return true, and if any of the cases returns false, I don't have to check further, I can just return false from there. But if they're not, you have to check the status. So over here, this is the main part. What you have to check is you have to check the first list. And due to recursion, we know that first leaf has moved to its end. So now from here, when we say using recursion, we are actually visualizing at the last value in our list nodes, as we have already visualized. So in that way, I can check whether first list value is equal to second list value or not. If they are equal, you have to return the status. And anyways, I'm always incrementing my second list pointer just for safety. So this code is one of the way to write our second approach. I can clear this comment now. This looks then more clearer. I can submit it out, and this works fine. So thank you guys. Hope you liked it. Hope you liked my presentation.